Welcome, everybody. And I'm looking forward to today's conversations about one of my favorite topics. As you know, I've been building games for a long time, and I have two absolutely fabulous colleagues who are here to speak with me about a new game that we're building today. My name is Matt Marino. I'm an exceptional education professor at the University of Central Florida. We go around the room, starting with you, Dr. Jessica Hunt, and would you introduce yourself, please, and tell us what you specialize in?
Sure. So hi, everyone. I'm Jessica Hunt. I'm an associate professor of math education and special education. I'm at North Carolina State University in Raleigh, and I specialize at that very intersection of math education and special education and the use of technology. So welcome to you.
Thanks. And Michelle?
Hi, everyone. I'm Michelle Tobe. I'm an assistant professor at the University of Central Florida. I'm in the Department of Learning Sciences and Educational Research. My research focuses on also using technology to investigate learning with advanced learning technologies, such as games. So really excited to speak with everyone today.
Well, thanks for joining us, ladies. We're going to be talking about supporting educators' use of game-based learning environments as formal and informal assessments today. And we're going to get started with a question for Jessica. The question is, how is the Dream2B game-based curriculum developed?
All right, so the idea for Dream2B came from an NSF-funded career award. And that award was to me a number of years ago, and it was called Fraction Activities and Assessment for Conceptual Teaching. That was a longitudinal program that confirmed stages of fraction conceptions and procedural development along a trajectory. So you can see a simplified version of that trajectory on the screen. And this trajectory was specific to students with learning disabilities. And what was interesting was that the results indicated that students with learning disabilities develop fraction concepts using strategies that are similar to students without disabilities. Now, those two groups differ, however, in the cognitive scaffolds that are necessary for success. So we developed an intervention program based on that trajectory, and it was found to increase fraction concepts and overall fraction knowledge for 4th and 5th grade students, both with learning disabilities as well as students who experience math difficulty. So I wanted to take the idea further and build a technology tool based on that same trajectory that did things like provided opportunities for students to both create and quantify fractions in game-based challenges, but also increase engagement and provide real-time strategy-specific cognitive feedback. And I think what was important for me most of all as a former teacher was to make the tool easy to implement in classrooms and to enhance or enrich what teachers were already doing. And that turned into Dream2B. So to put it simply, our theory of change basically says that if we have students and their teachers using Dream2B, which game-wise has the core components that you see listed on the screen, for a number of weeks, that we'll see significant increases in their engagement, in fraction knowledge, as well as STEM interest.
Great. So what I hear you say is you developed this game with your NSF Career Award, right? And over time, you realized you wanted to add this new component, which was going to be the game-based learning, Dream2B.
Absolutely.
Let's take a look at it right now.
Sounds good.
There are many elementary mathematics curricular materials aligned with national standards. Unfortunately, many of them are not engaging to students. Perhaps you remember the joy of completing fraction worksheets in elementary school. Students with disabilities are an underutilized source of diversity in science, technology, engineering, and mathematics careers, as well as information and communication technology professions. These career fields had more than 2.4 million unfilled jobs last year. STEM and ICT career opportunities for people with disabilities will continue to expand over the next decade as society embraces the technological benefits associated with machine learning, artificial intelligence, and renewable energy. However, These careers are only obtainable if students achieve an accurate conceptual understanding of fractions in elementary school. Dream2B is designed to reinforce cornerstone fraction skills like partitioning and iterating in Tier 2 mathematics classroom. Let's take a look at how this works. Students begin the game by customizing their character. The diverse array of choices allows students to choose attributes that align with their racial, ethnic, and gender identity. This provides a hook to engage students in the learning process. They play through immersive problem-solving activities that promote visual attention and reflection on their thinking across 5 STEM and ICT career worlds and subsequent sections of the game. The game begins with a tutorial where players learn and demonstrate core gameplay mechanics in the game. The free cut tool allows the players to freely partition a bar. With grab, we can move objects around. Equal cut helps partition, but equally. Repeat allows us to iterate and make a copy of the piece. Sewing allows us to combine 2 pieces together. In World 1, students step into the world of a wind technician, where they learn to partition wind and iteratively send parts to turbines that convert the wind into energy. In World 2, students take on the role of a solar panel technician, where they engage in distributing solar panels to homes to create solar energy. Players must use partitioning and iterating to determine the equal share of panels each site needs to receive. In World 3, players step into the life of a fire inspector, where they combine or iterate unit or non-unit fractions to check for code violations. Students work with different materials across contexts using partitioning and iterating together, and even create and use non-unit fractions to simulate the primary burn zone in an explosion. World 4 features the career of a photogrammetrist. Students use partitioning and iterating to reverse a non-unit fractional projection of a rectangular land to find its original length. In World 5, students use recursive partitions to write programming block units. To test their code block, students must determine the value of quantities created and refine them if they are buggy. The teacher can set the minimum threshold proficiency level of gameplay mechanic mastery in the tutorial using the teacher dashboard. This means if a student struggles to complete a level in the game, the teacher can be 100% certain it is because of conceptual misunderstanding, not because the student hasn't mastered the core gameplay mechanics. Players can play the game using multiple types of controllers. This allows students with a diverse range of physical abilities to play the game using familiar hardware that meets their individual needs and preferences. This also reduces the amount of time necessary for students to master the use of controllers. Players can customize the game with settings. Change colors in the game using a color palette to make it aesthetically accessible for you. Adjustment of sound output is an extremely valuable asset to teachers who may have multiple students playing at the same time, or while other students in the classroom participate in different activities. Dynamic hints throughout the game's levels provide teachers with evidence of student understanding based on patterns of student behavior. For example, in World 2, the player must distribute equally. To do so, they can use 2 different strategies to solve the problem. One way to solve is that we could distribute whole units and partition the last piece, or we could use the number of sharers as an input for partitioning. The game also includes multimodal information, including text-based information, spoken audio overlays, and color and symbol-based conveyance strategy to maximize the speed at which students can master the content. Throughout the world, players will learn about different conceptual understandings of fractions. Success at the elementary level can lead to advanced coursework and a future career in STEM and ICT discipline. Dream2B teaches fractions while introducing students to some of the fastest growing STEM and ICT careers. Play the game today. We would like to thank the National Science Foundation for their generous support of this project under award number 1949122. Any opinions, findings, conclusions, or recommendations expressed in this material are those of the author and do not necessarily reflect the views of the National Science Foundation. There are many elementary math.
I think it wanted to play again there.
Well, it looks like a super cool game. So tell me how you would teach a teacher how to use this game in their classroom.
Well, I think before I can answer that question, I need to comment that the game itself is actually embedded into an overall curriculum. And that curriculum reflects the elements of the original career program, but improves upon them greatly. So it's important to remember that the game is part of that curriculum, but there's also a preview, which lasts about 5 minutes. And it's really just to introduce the gameplay for a particular world, or introduce students to the STEM career in that world. Then there's the gameplay itself. Then there's the after game connection tasks. So I think, going back to your question, we would want teachers or as teacher educators, we would want to support teachers to understand both the design of the game, the design of the curriculum, and the mathematics it supports. And I can talk more about that in a little bit.
Great. Well, I see you've got the slide up here that has lesson preview, and I assume that this is the teacher that's going through that, right? And they're actually going to go through and play Dream2B, and then they're going to formulate some means to have an after game connection with the students through discussion or something like that.
Yeah, absolutely. The point of the previews is they're very short. They're only about 5 minutes long. And what they're really trying to do is either introduce the game narrative, which basically is that Bunny has gone to a STEM career fair and is having all of these ideas about whether they want to shadow one or more of the STEM career experts, but they're not sure. So they go home and they fall asleep and they start to actually dream about these different careers, and that sort of motivates the gameplay. So the preview is helping kids sort of understand what's going to happen in gameplay, or explain more about the STEM career that's happening as a part of gameplay for that particular day.
Great. All right, so tell us some more about the game.
All right, so it's also important to remember that the game itself was designed very purposively. And what I mean by that is that it was designed to provide access and engagement through universal design for learning. It was also designed to provide opportunities for students to create and quantify fractions in these game-based challenges. So through the tasks and the sandbox play in the game, they engage in these challenges, which actually promotes their knowledge of fractions. And finally, it was also designed to support students to think through their gameplay. So that's what the use of what we're calling cognitive feedback is for. So this slide, for instance, is just showing a few of the universal design for learning components that Dream2B has built into its user interface.
Excellent. So, folks, I didn't say this early on. I should say it now. Please, if you have questions for us, post them in the chat as we're going through, because I'm sure that Dr. Hunt and Dr. Tobe have responses all cooked up for you and are ready to deliver them at a moment's notice.
Yeah, I do see one question in the chat about describing the research piece of this game. Certainly. So it's really a three-part, I think of it as a three-part process. The first part was getting to what's called an alpha and then a beta version of the game. So generally that involved looking at all the gameplay mechanics, building out the tasks, the worlds, the art, etc., and then getting that to a version that was fully playable from start to finish. And along the way, we would do iterative play tests where we would test out components of the game, get feedback, and iterate or improve on those components. What we're in right now is called a feasibility study, which basically means that we have the game and its curriculum, and we've partnered with 2 schools in North Carolina, 2 schools and 8 teachers. And we've asked them to implement the curriculum and to give us feedback on its alignment to standards, its pacing, whether it added value to instruction that they already have. Dream2B is a supplemental curriculum. So it's not meant to take the place of core instruction. It's meant to supplement it and to add to it. So we're collecting data from teachers via focus groups and interviews, but we're also collecting data from students in terms of their fraction knowledge before and after engaging in the curriculum. And we're also looking at their engagement via analytics along the way.
Excellent. And Julie Martin would like to know what the name of that math curriculum it is that it's been embedded in.
It's actually a curriculum that we created. It's a wraparound, if you will. So there's the Dream2B game and also the larger curriculum that wraps around it, if you will. So it's got the preview, the gameplay, and then the after game tasks, which I can describe shortly. But basically, those take the shape of either a worked example or a number string. And the purpose of those is either to directly connect to concepts in the game, to give students opportunities to really process particular gameplay strategies and why they may be really efficient or really inefficient in some cases, or to compare strategies, while the number strings really look at ways to connect symbolic notations of fractions and things like comparing and ordering, and even operating on fractions to their gameplay. So all of those are things that we created for this project.
Thank you. The next question is going to Michelle. And Michelle, your question is, how does Dream2B integrate learning and assessment?
Thank you, Matt. So Jessica, if you start with the first slide. So as we were developing, or while we're developing this game, we wanted to make sure that us as researchers, but also teachers, would be able to investigate learning in two different ways. So we have the learning process and we have the learning product. So the learning process includes, what are students doing during a task? So in our case, in this game, what are students doing while they're playing Dream2B? What kinds of strategies are they using? In comparison, the learning product includes the outcomes from the learning experience. So how many levels did the students complete, or how are they performing on a test? And we think it's important to make this distinction because we want to make sure Dream2B is fostering the learning process. So are students learning the mathematics concepts in the game, or are they just trying to figure out how to beat the level, which we would argue we would prefer they're learning the concepts as opposed to only trying to beat that level. Of course, we also want students to perform well on the tests and be able to solve tasks, but we also want to know how they got to solving them. So how many times did they attempt to solve the task? If they got it incorrect, did they change their strategy when they were trying again? So these are the kinds of questions we're interested in investigating by looking at the learning process. And if you go to the next slide. Oh, sorry, I did say all that, I'm sorry. So how can we investigate both the learning process and the learning product in games? So this is where gameplay analytics come in, and I'll talk about it even more after too. So we're planning on capturing students' gameplay analytics, which basically measures their learning processes, again, during gameplay. So using the analytics will help inform the teachers what their students are actually doing while they're playing Dream2B. So again, what kinds of strategies are they using? Is this demonstrating their understanding or conceptual understanding of fractions? Hopefully it is. So again, we still want to know the learning product, and the gameplay analytics will be able to generate or be able to give us information about both the learning process and the learning product. And if you go to the next slide. So as Jessica already mentioned, the game does include nudges that are built to improve students' cognitive processes. And one way we are trying to do this is to foster student self-regulation during gameplay. And this provides students the opportunities to be independent learners or independent game players. When students are self-regulating, they're basically, they're being active learners. And they're doing that by engaging in strategies that are related to planning, monitoring, and self-reflection. And research shows this can be beneficial for students, and it's important. It's also an important component of universal design for learning. We also know that students often struggle while self-regulating. So we felt it was important to try and foster these strategies or these skills within Dream2B. And that's why we developed these nudges within the game. And again, when we're investigating self-regulated learning, we are investigating those learning processes. And we're asking questions about how long are students spending planning or thinking about how they're going to solve that task before actually solving it. And then again, we're looking at the strategies that they're using. Do students start by partitioning, or do they start by using a different strategy? What happens when students get something wrong? Do they reflect and try a new strategy, or do they try the same strategy over and over again? Do we see evidence of this based on how they're moving the mouse around? And I guess a spoiler, we're going to show you some videos, so maybe we'll see some of that evidence. So basically, as you can see, we have a lot of questions that that we can use to assess how students are self-regulating and demonstrating their conceptual understanding of fractions during gameplay.
Thank you, Michelle. I will say that when I was developing games for middle school science, what stuck out to me the most was that my middle school students were really struggling with self-regulation. So I think it's super important that those aspects have been built into this game.
Yep, absolutely.
My next question is going to come back to you, Jessica. And the question is, how are we supporting teachers during the pilot project?
All right, so teachers, as I mentioned, are partners in this work, especially throughout the project. But now that we're asking them to actually implement it from start to finish, there are two main elements of how we're supporting teachers that I wanted to mention. And the first is supporting how they anticipate possible student thinking or strategy use within the game. So we'll start with that. One way that we support teachers is by helping them to understand the thinking they might see in the game through students' employed gameplay strategies. So we do this by using what's called video analysis. And this is an actual slide out of our PD program that we use with teachers. So the video that I'm going to play, it doesn't have any sound, and it's meant to be very short. It's showing a possible strategy for this task in the game, which is 5 solar panels shared among 4 houses. We ask teachers to watch the video and to notice and discuss their strategy, meaning the student's strategy that they see in this video. So things like the tools that students are using to support the strategy and what the strategy may reveal about the student's concepts of fractions. Research suggests that video analysis within and across a range of possible strategies actually promotes teachers' anticipation of student thinking and can actually improve their teaching. So for us, the use of this video analysis in PD supports an important implementation goal. And that's that during gameplay, we don't want the teacher to be silent. We don't want teachers to take a break as students are playing the game. We want them to watch and observe gameplay and be ready to talk with students about their gameplay strategies. So our PD and our teacher guides as well, and you see a portion of one on the screen, actually helps teachers understand what gameplay strategies they might see, as well as what types of questions they can ask students to support their thinking as they play the game. The idea for those materials actually came from my own experiences. I was a 7th grade math teacher in a technology school in Florida, and I had a lot of great technology tools, but I often found myself wondering how to make my own role more active as students were using them. So these teacher guides and materials are a nod to that experience. So in looking at the materials, one possible strategy in that World 2 problem that we just looked at is using trial and error or having strategy to partition and distribute the solar panels. So if a teacher saw that, they could use the materials and say, well, how did you know to make that many parts? Or is there a way to know ahead of time how many parts you might make? And that's just meant to further provide those nudges and to supplement the nudges that are in the game to further support students' reasoning. We also give teachers watch fors and brief directions, as you see at the top of the screen there. And that's really just helping teachers keep engagement and learning going as kids play. Importantly, they're also helping teachers informally assess how students are reasoning in real time.
That's really a critical aspect, Jessica. I know when we were doing the science research, many of the teachers felt like the researchers are here and they're having the students play their game. And so I'm just going to go sit as a teacher at the front of my desk and I'm going to do some grading while the students are playing through the game. And the point that you brought up is just critical. They need to be walking around, talking with the students and asking questions in order to foster that larger conceptual understanding.
Absolutely. So that kind of goes hand in hand with the other thing I wanted to mention in regards to your question about how we're supporting teachers. And that's through really supporting them to understand how to implement that after game connection task. So remember, that's that third thing that happens as a part of our overall curriculum. We preview, the kids play the game, and then we step out of the game and play an after game task. And for us, one of those types of tasks are called worked examples. In Dream2B, our worked examples give students opportunities to first self-explain, then rehearse or share their explanations with a partner, and then finally revise their explanations before they share with the whole group. So in the PD, the teachers are actually stepping into the role of the students so that they can get a sense of what their students are actually experiencing in the curriculum. I step into the role of the teacher along the way to model the routine of a worked example so that teachers can see that part as well. So again, these are slides that are from our actual PD materials. This one's showing a worked example in World 2, the solar installer world. And here, Gloria, the solar panel installer, is sharing 5 panels among 4 houses, like you saw in the video. So teachers are given the student pages for this task so that they can use them. And then I launch the task and read right from the teacher guide so that the teachers can see, can experience what students are experiencing again. So I would say something like, I want you to explain to yourself the work shown for this task and why it leads to an equal share of the solar panels. Here are some questions to help you. Try to address at least 3 of the questions to write your response. And then teachers would use the student pages to write a self-explanation. They then move on to a partner share. So I would say something out of the materials there, like, now is the time to discuss your explanation with a friend, work with your solar partner. One partner first explains, then the other listens and responds, and then you switch before moving on to the final group share, which is where I, again, would model from the teacher role how to select students to share their explanations and justifications, how to promote students to use the sentence starters that you see on the screen, because oftentimes students need support in actually knowing how to explain and share with others. So these sentence starters are scaffolds to help them do that. And then the teacher actually uses these talk moves to facilitate the discussion. And in the PDs, I would model the use of these talk moves. Again, they're purposeful scaffolds to aid students' discussion with each other and with the teacher. And I think the best part of this experience is that we step out and then reflect. So teachers were in the role of students, then they step out and reflect using a lot of the questions that you see on the screen. Doing that, I think, helps them implement the task as it's intended, which is shown, this is another part of our teacher materials. So having that experience really helps them understand the intent behind what you see in that teacher guide.
The question prompts are fantastic. And I love the way you laid it out so that you walk us through exactly what a teacher would experience during the professional development activities. I think that's critically important for us to be modeling for students when we're working with future special ed teachers so that they understand the importance of having those explicit models to bring to the classroom, right?
Absolutely.
All right, so I want to talk a little bit about game-based assessment. And Michelle, that's you.
Yep. So this is where I get really excited because I really love data. So I'm going to try to calm myself, but I really do love the data portion. I mentioned the learning analytics before in terms of collecting process data. So I just want to talk a little bit about how we're actually going to be capturing the analytics in Dream2B and how teachers will be able to use the types of data as formative assessment. Sorry, the next slide. That's just the definition of learning analytics. So you saw before in the video that students can solve the tasks in different ways by using these different tools. And if you go to the next slide. So as you can see here, here in the table, this is the way that if students are using these tools, we capture that from the gameplay analytics. It can demonstrate how students are using cognitive processes and what are their levels of conceptual understanding of fractions. So we can see all the tools are at the top there. So students can repeat a behavior, they can cut a bar in half. They can also reset the level or undo their move. They can also ask for help. That's what the bunny phone is on the end. So I'm not going to go through all the elements in this table, but we just wanted to show that here we can see that the way that students are using these tools can actually demonstrate their knowledge acquisition, their levels of attention, how they're managing their time, or how they're metacognitively monitoring or conceptually understanding fractions. So we know all this based on how collecting information about how many times they're using a tool, how long are they using a tool, and all this, I had the word proportion, so that is all in relation to how they're using other tools and how they're spending time in the game. So are they spending a particular amount of time using the equal cut tool, let's say, compared to all the other tools? So in general, this is just a way to show teachers how we can use the analytics to examine how students are learning in the game. So we get tons of data, which again is why I'm excited. If you go to the next slide, basically so what does this actually look like in Dream2B? And then if we go to the next slide, we have another video. So this is to show how a student might be solving the task. So if we see, you can start the video. So we see here, I won't get too ahead, but the student is basically, they're making a guess. So they're cutting a bar, and then see here, they got it wrong. So what's interesting now is what they do next. So I'll give it a second, but we'll see here the student, so they restart, and they're gonna make another cut. So as we see, the student made the bar longer and it was too long. What's interesting is what they added was the amount that they were short by on the first round. So what does that actually mean about their understanding? And I'm going to let Jessica talk a little bit more on the next slide about that, but it's just very interesting to see the process of what they did.
Yeah, so remember that the sequencing of the tasks in Dream2B is based on what we know about how kids develop different fraction concepts. So that's to say that there are different stages that kids tend to develop as they, for instance, in this world, think about the magnitude of a unit fraction in relation to the magnitude of a whole. So what we saw in the video was a student who was adjusting the size of or the length of the win bar correctly, but to make their next guess, they were actually adding, as Michelle mentioned, the entire amount that they were short onto the next bar. So that tells us something about how that student's thinking, namely that they're still trying to coordinate the repeating of that bar with the length of the entire WinBar. So it gives us really nice formative information about how students are currently reasoning, as well as where their learning might be going. So the analytics are very powerful in that way.
Yeah, so we also just wanted to show you what we're planning for the teacher dashboard, and you saw that in the video that we watched before. So this is what we're hoping it's going to look like. So as you can see, the dashboard is demonstrating students' mastery across the different levels, so across the different STEM careers, and we're seeing their different levels of mastery, and that's a great way for teachers, a way to demonstrate to teachers that we can see students' process data and also their product data. So this is a great way for teachers to remain involved, to monitor how their students are doing, how they are mastering the content. We believe this is going to be a very powerful tool for teachers.
And in fact, when we did this, I do want to say that this also applies beyond math, right? So if we're teaching folks to use games in math class, should also know that these games or similar games can be used in any subject area to actually give us a better sense of what teacher or students know and can do. When I was working in the science classroom, the teachers continuously came back to me and said their post-test scores on the paper and pencil tests are not indicative of what they actually learned from the game. Their gameplay analytics were a better way to determine what they know and could do because they were successful in that environment. But when you put it in print, then you had all of the complications associated with their disability, which hampered their performance. So I think now seeing this from my perspective, starting in science and going to math and seeing the same types of results coming forth is really exciting for me.
And great
plug. The last question, I think, Jessica, or I'm sorry, Jessica, is going to go to you. It's going to be supporting pre-service teachers' use of games in their classrooms. What do we do?
So I'm not sure if I have all the answers, but I do have a couple suggestions or overall thoughts to think about, especially from the lens of teacher educators. And the first would be to really, if we want pre-service teachers to value the use of games in classrooms, then we want to connect the use of games to the overall goals of our teacher preparation program. So when we talk about teaching, assessment, and equity and diversity, for instance, how does the use of games support those areas? So I think in terms of looking programmatically, we would want to hear consistent messages about how games and other technology tools can really support the work of teaching in each of those areas. For instance, the great points that have been made about analytics and the processes of learning. So as we're learning about student learning, we would want to mention the use of games consistently across our program whenever we talk about teaching and learning, whenever we talk about assessment and equity and diversity. We would want to really highlight and showcase through a consistent message in our programs about how the use of games really can support the work of teaching in each of those areas. And I also think practically that we want to think about frameworks and resources that we can use, that we can give to pre-service teachers so that when they start to work in classrooms, that they can carry forward the use of games in their classrooms. So for instance, universal design for learning is one design element that's embedded in Dream2B and other technology-based tools. So I think if we can give teachers ways to talk with colleagues and talk with administrators and other school personnel about how games can support access and advancement through things like universal design, that it will actually make their use of games in the classroom much easier. Other things like evidence of effectiveness, again, in aiding in those conversations with colleagues and other peers in schools and districts. Curriculum resources. This was a big one for me because, again, as a teacher, I had a lot of technology tools, but oftentimes wanted more information about how these tools could integrate with the curriculum resources that I was using. So I think frameworks or tools or ways to help teachers see, whether it be through connections to standards or something else, how the use of games really connects to the good things that they're already doing becomes really fundamental. And I think, finally, just as a practical sort of recommendation is, show how games work with teaching as opposed to becoming like just another thing, or maybe even I've heard, replacing the work of teachers. Games don't do that. What they do is give us a tool and a resource to make our teaching better. So, even beginning with that core message, I think is just really, really fundamentally important.
I would agree with you, Jessica. And I think that it's critical that we have a way to engage our students who may be sitting in a math classroom and not engaged because of the paper and pencil nature of it, and get excited because of the game that you were able to build. So kudos to you guys.
Yeah, thank you. Again, just connecting back to my own work as a teacher, I can tell you that anytime I could connect mathematics to technology or gaming, students would literally beg me because, often, something that my former principal said to me a lot is, kids come to school and they power down. Now that was 10 years ago, but I would say in some cases that may still be the case. And your comment about engagement becomes extremely relevant because, we want to give kids ways to really connect their lives with mathematics and other curricula in schools. And I think games may be one way to do that.
Absolutely. So what I would say at this point is I hope everyone will take a look at the comments. I posted a link to the CIDDL community where you can go ahead and log in and ask us questions in the community. We're hoping the conversation will keep going after this. I know that there are a couple of blog posts that will be coming out highlighting the aspects of our presentation today. And we're all in there and waiting for you guys to come in and ask us questions. So you can either shoot us a direct chat or make a comment to the blog post. But do know that we look at those and are happy to reach back out and connect with you. I also want to say that if you are a teacher who's interested in piloting this, you can go to the modelmemath.org website and complete a consent form and go ahead and try out the game and see if it's something you might want to implement in your classroom. So Jessica, why don't you tell them a little bit about this study, just for, give a 2-minute overview of what it means if I'm a teacher and I say, I'm interested in using this in my classroom.
Sure. So that would mean that you would come and work with me for a couple of half days. So the purpose of that is professional development around everything that we just talked about, the trajectories of kids thinking, how to use the curriculum, step in and step out as students, and then as teachers, and practice that with your peers. But then after that, we would ask you to implement the curriculum, which would be at least 3 times a week for at least 11 weeks. They're short lessons, they're only about 35 minutes long. And we're finding currently that that seems to be holding pretty true for folks. So we're excited about that. And we also offer, check-ins. I offer sort of very, very informal coaching and check-ins with teachers who are implementing the curriculum. And then talking with us about what you thought of it. Was the pacing okay? Did you find it connected to your standards? Did you find that it supplemented or enriched things that you're already doing to teach your kids fractions, things such as that? And those would be done via focus group, which basically means people come together as a group and talk about their experiences implementing Dream2B.
Great, thank you so much. So if you're in the audience right now and have another question for us, we'll give you a couple minutes to type that question in. While we do that, some concluding remarks, excuse me, from me. I would like to say that working with this team has been a fabulous opportunity for me. We have a group from the Florida Interactive Entertainment Association, FIA, where we were able to recruit this game building team. They were absolutely outstanding. And we look forward to working with them some more in the future on it. If you have a game that you're interested in having our team build, please reach out to me and contact me, and I can facilitate that and make it happen for you.
Yeah, likewise. This has just been a great experience. Again, kind of seeing my one version of my curriculum become Dream2B has just been wonderful. It's been something I've been wanting to do for a long time. So the whole process has just been really interesting, and I'm very much enjoying this work. So it's just been great. So, and we appreciate the opportunity to come and talk with everybody today as well.
Well, thank you very much for joining us, and I hope you all have a great remainder of your day.
Thanks, everyone.
Thank you.